Awesome. All right. So, so this is more of a continuation of the first session itself. Since it was a lot of information, I had to break it into two pieces. Um, so in the first session, we went over the whole foundational model of multi-cloud networking, imposing security on top of it. In this session, we specifically want to talk about opinionated deployment model that we have been recommending as Google Cloud to our customers who are accessing services, AI services across multiple cloud at scale. How do you make sure you access those services, but at the same time, there is a simple security solution on top of it? So, so why are all these applications getting distributed, right? So let us go from left side of the slide here. So enterprises are increasingly moving to services-based architecture or SOA, service-oriented architecture for app dev, right? With DevOps team building services that can be reused by multiple applications. Now, running these services in every single cloud tends to become super expensive, and it slows down the pace of application deployment. So enterprises, what they have done is they have started to rely more on best of the breed SaaS services that are offered by each and every cloud provider, or there is this whole concept of pure play vendors to build these composite applications and accelerate your application development. In many cases, we see that there is no luxury for of these services being available across on-prem and different cloud providers. And lastly, the biggest trend is that Gen AI customers, they are experiencing an increase in cross cloud dependencies. Now, these enterprises are trying to efficiently use all the available GPUs and TPUs out there that is scattered across multiple clouds. Now, people who've been working on this Gen AI and who wants to run their own models, you know that it's A, super expensive to find GPU and TPU, and B, even with major cloud providers, uh, there is a capacity constraint, right? So enterprises out there want it, and that's why they are going to multiple clouds to get GPUs and TPUs. Modeled most suited for your enterprises may require you to expand to other clouds also to get those capacity. And finally, your data required to train the AI models may not coexist with the GPUs that are available. So your model could be in other cloud, but your GPUs could be in other cloud because that was the best option available at that point of time. So what you see in this slide is a very popular deployment model using a global landing VPC in the center over there that enables a full mesh connectivity between the workloads and services hosted across different regions, and I also either in on-prem or other cloud provider. This model uses end-to-end IP routing based connectivity for reaching from point A to point B. Now, I don't need to kind of belabor the point, but I'm sure all of you are intimately familiar with the operational complexity of routing when you are building highly available architectures with workloads and services, not only running in multiple regions, but now it's going to run across multiple clouds. There is no way where you can assign a clean IP across multiple regions, across multiple cloud providers. IP overlap is a nightmare for network engineers, and your app team is continuously asking you, hey, I need to build this Gen AI workload in cloud A, cloud B, cloud C. And how do you figure out that the routing works across this overlapping IP space? And on top of all this, when you do NAT as a solution, which is like most of us network engineers do to solve overlapping IP issues, there are this unintended consequences of network security because your original client IP is lost now. So these are some of the challenges with your existing routing model. And finally, lastly, these are dynamic environments, right, that need to adapt to intended and unintended changes. It's almost impossible for routing to respond to active health checks and proactively fail over before as a service goes offline in this case, right? When is the last time, let's say, you tried to use routing for traffic splitting, or do some sort of AB canary testing? It's pretty difficult to do that at an IP layer, right? So that's why this whole concept where now you have to add security on top of this routing base becomes even more challenging, right? People have been using this common pattern of spinning up third party virtual firewalls in the cloud, but these firewalls are running on top of a VM. Each VM, whether you go to Google, Azure, Oracle, any cloud provider, has a certain capacity. And it starts becoming a choke point because these firewalls are not only doing security, they are also inserted as a routing point, right? Because all the traffic needs to go through it. And then it start becomes operationally cumbersome since this appliance uh, cannot scale after a point, cannot fail over dynamically, and to maintain them you need a plethora of network engineers or security engineers just to do that. So overall your TCO is going through the roof. Layering advanced preventative security like zero trust access, service rate limiting, DLP or data loss prevention is even more challenging because of lack of uniform enforcement points in this kind of a model, because this is more of a centralized deployment model. So these popular deployment models create a complex web of dependencies between the three different personas that you see here. The DevOps team has to rely on the NetOps team to provision this VPCs that you see, and the NetOps team have to make sure that this VPCs have a unique IP space and routing is enabled between them. Then the SecOps team and the DevOps and the NetOps team work together to figure out how am I going to place this multi-NIC firewall into the mix over here. And then the SecOps teams are at the mercy of DevOps team to implement necessary security controls all the way up to the application VPCs. Now, these dependencies are usually resolved via traditional ticketing process that I think most of the enterprises have there, but it kind of hampers the velocity at which you as your developer want to deploy your applications across clouds. Also keep in mind that these workloads and services span different platforms, right? It's not just about spinning it in VMs. We have gone to containers. We have also gone to serverless. Services themselves can be native, like SaaS provider, partner SaaS provider, or self-managed categories. So using a custom connectivity and security model for each of this like kind of permutation and combination becomes even more difficult, and it's kind of really difficult to scale it after a point. So at the beginning of cloud journey, most of us treated this as an opportunity where we can get a fresh start and build a simple clean network and have a robust security posture. But as you start expanding across clouds within your cloud, more and more business critical application and sensitive data, as soon as it starts coming into the cloud, you want to tighten your security without increasing the complexity of networks or routing. So these requirements were top of the mind as Google designed the whole concept of cloud NGFW, which is nothing but next generation firewall, from the ground up itself. So let me kind of quickly dig into the detail of how we were able to achieve this. So Cloud NGFW is a fully managed cloud native solution, meaning it is a distributed firewall service integrated into our SDN itself with a virtual fire engine following each workload throughout its entire life cycle. What I mean by this is this is not a single VM, or this is not a multi-NIC appliance that the customer has to worry. How do I inject it in the path to make sure that security is implemented? What this means is that we have gone all the way to the underlying fabric itself and made sure that when a packet enters or leaves the VM, it gets inspected every single time with the security policy that you have configured. Now, this is very powerful, right? Because you get this guarantee as a SecOps person without relying on NetOps person to figure out routing, that every time when a packet is going in and out, you are able to implement layer 3, layer 4, and all the way up to layer 7 controls. uh, you can even do TLS inspection with cloud NGFW endpoints. So, so this technology that we use under the hood is, and there's a white paper out there which is called packet intercept. What it means is that before the packet goes to the VM, we intercept the packet, we take the packet and we put it to our cloud NGF endpoints, which are zonal. This cloud NGF endpoints under the hood are powered by a fleet of firewall engines, and we have partnered with Palo Alto Network, which leads the security in the industry right now. And so each and every packet then goes through those engines, and the packets are then put back on the wire to send it to the workload or the VM itself. Uh, in terms of scale, the customer doesn't have to worry about, let's say your workload is running on Kubernetes, right, or GKE. It scales up and down depending on your load. Customer doesn't have to think about, oh, I need to spin up a 10 gig firewall or a 20 gig firewall. That is completely handled under the hood by Cloud and GFW. So the only thing customer has to do is worry about their application and leave the networking and security to Cloud and GFW. Now, Cloud NGFW also has this whole concept of integrated government, integrated IAM, which is Identity and Access Management govern tags. I think this is something which our keynote speaker was referring today about, the granular control that you get with IAM to do micro segmentation. So let's say you can, for an example, you can bind the IAM governed tags all the way down to the VM itself and say that, okay, if this IAM governed tag is applied to this VM, then only inspect the traffic with green policy. If it is not, then apply blue policy. So each VM also can get its own set of policies, which is what you want in a micro segmentation environment, right? Because your green VMs maybe are, let's say, service A, blue VMs are service B, microservices, so on and so forth, right? So a tag-based rule can be programmed as a threat response action. And then let's say, for example, bad things happen. All you need to do is put the special tag on the infected system to quarantine it and prevent it from any lateral movement of the threads. So we also have this whole concept of hierarchical firewall policy deployment model. Now this is super powerful, and Google was the first in the cloud to bring this technology. Let's say you want to implement a firewall rule at one VPC level. That's pretty simple. But now let's say you are a big enterprise and you have hundreds of VPCs, or maybe let's say thousands of VPCs spanning hundreds of projects. How do you do it at one place? So there is this whole concept of hierarchical firewall policy. What happens is you as an administrator go all the way up to org level. So org is a concept, let's call a virtual concept. So an example would be, let's say you have a company called example.com. So that's your org. Within that org, you will have different folders. Let's call it prod, dev, test. And within those folders, you will have a bunch of projects. Now, you as an org admin can go all the way up to the top node and say, let's block port 23 across the board. So you want to block telnet port. So that's just an example, right? Now, depending on what you want to do for each and every environment, you can apply it all the way at the top. So anytime, let's say you have an employee or you have a malicious user who comes up and spins up a resource in a project and wants to do something bad, you are still protected because your org policy will be inherited all the way down to the project, all the way up to the VM level itself. So this is a simple security posture management all the way up to the top of the hierarchy. So there are certain policies. For example, you want to block traffic to embargoes countries, right? As a user, right? So you can just apply it once, it gets percolated all the way up to each and every VMs, and this shows you the scale at which how powerful this can become, right? So again, this is one of the pain points that we have heard from many of our customers is that how do you between the selection of operational complexity and figuring out a managed cloud native service that offers a high threat efficacy rate, right? Customers have in most of the cloud have been using Palo Alto virtual appliance to protect themselves from perimeter security, and because Palo Alto has the highest efficacy rate across the board, so what we decided to do is let's give you best of the breed with a managed solution by Google Cloud, but powered by the engine of Palo Alto for TPS or threat prevention system, and also use Google's intelligence system, by the way, which is also used by Alphabet for YouTube, Gmail, which naturally protects you from all the malicious IPs because it is scanning across the globe. So you get the power of both the databases over here in a managed solution itself. So this cloud NGFW kind of is offered in three flavors, what we call essential, standard, and enterprise. The essential is like kind of it comes with no cost. It gives you the basic protection. The standard one gives you Google Cloud Threat Intelligence, URL filtering, IPS. But if you want TLS all the way up to layer 7 inspection, that's where you use the enterprise version, which protects you from all the way from layer 3 to layer 7 itself. And again, from a user perspective, the distribution of the firewall as a service is all under the hood. It's just about which kind of policies you want to use and which tier you want to use. You may start with essential and then move to enterprise, and there is again zero downtime with the migration effort itself. So we also introduce a new concept of service-centric networking. This accelerates the application deployment process in this whole concept of how you can publish your services across the network and still enable consistent security across the board. So I'll quickly dive into it. So service-centric cross-cloud network is a very opinionated deployment model with a set of innovations that enable this whole architecture. So you as a user can now spin a bunch of workload VPCs, not worry about the IP space, not go to the networking team. The application team can publish their service in the customer managed services and give a PSC endpoint, which is a unique IP address to all their workload VPCs. Customers can then also access third-party services like MongoDB or Confluent through the PSC endpoint. And if they want to use AI services, they can access that using PSC for Google API's endpoint. Once you have all the PSC endpoints in the landing VPC, you can propagate this endpoint using NCC. What this means is this endpoint is now available, this unique private IP is now available not only to the workload VPCs in Google Cloud, but also to workloads that are running in other cloud providers or other data center of customers. So just to add over here, there is a bifurcation of duties between the two personas over here. The NetOps team, the DevOps team is the one who is publishing the service. So their job is only to spin up a PSC endpoint, and the NetOps team have the control of who can access these PSC endpoints throughout the network. So with the combination of two, the customers can the developers duty is just to have the endpoint itself, and the networking team decides whether that endpoint should be accessed across the cloud or just within the cloud. But there is one more pattern over here. Sometimes what we have seen is the managed service itself of the app team wants to talk to, let's say, a BigQuery. How do you achieve that? In order to do that, we have this whole concept of PSC interface, wherein it's almost like a multi-nic interface. Think of it as an interface which is one leg is sitting in the customer managed services, the other leg is sitting in the service landing VPC. From there, it's able to access the PSC endpoint and access BigQuery. So you may be running your own version of data lake over here, which needs to access BigQuery for certain analytics. So you can achieve this using PSE interfaces. And similarly, if the Google services like an Apigee gateway wants to talk to an on-prem database, you could leverage the same PSE interface to go out through the interconnect and access your database on-prem. What this pattern is giving you is a bi-directional connectivity without worrying about IP overlap. Yeah, so this whole concept that what you just saw over here is what we are referring as PSE everywhere. What it means is that you can use PSE negs or network endpoint groups in the service landing VPC to expose your application services, and now you can front end it with an application load balancer. Now, what does this load balancer bring to the picture? It gives you two powerful things. Number one is that it gives you granular traffic management between your workload and services through progressive A/B rollout, through regional failovers as well, because it does the health check. So as so far we've been focused on the whole concept of publishing your services in Google Cloud, but we have customers who also have their services running in AWS, other clouds, or even their own data center, and are still in this whole process of migration. What are the options for them? Let's say the customer has workload in Google Cloud, which has certain dependencies outside of Google Cloud. What they can leverage is this whole concept of hybrid neg or hybrid network endpoint group. What it means is you spin up a load balancer, you put a neg which is a backend to that load balancer, and within that neg you specify the on-prem virtual IP and the port number. And this allows your Google Cloud workloads to access your on-prem services running in either on-prem or other cloud. The next variation deals with this concept of cross VPC backends, meaning I could have my developers spinning their application in a bunch of VPCs, but I have a centralized networking team who's managing the load balancer in the service landing VPC. What happens over here is that the application team just has to tell the networking team that, hey, my services are running all over in different VPCs. Can you please load balance those services? So the centralized networking team will spin up the load balancer, implement all the routing and the traffic canary deployment models over there, and now all the services can be accessed through that single load balancer. So your with cross VPC backend, you could have backends spinning across multiple VPCs, but you just need a single load balancer to manage it. Okay, so to summarize the service-centric cross-cloud network model, we have kind of coupled it with the innovation capabilities of both consistent connectivity to Google Cloud native services using PSE or Private Service Connect, and also how you could access your on-prem workload using hybrid NIC. Okay, so let's do this, right? Let's quickly go over the concept of introducing security at the LB layer itself or at the load balancer. So far, what you saw is there is an option to create firewall policies at the workload itself using Cloud NGFW, but we are also working on this whole concept of service extensions, which is like behind a load balancer, you could implement any service of your own, and in that you could have a firewall as a service itself. So now what this gives you is that when the traffic hits the load balancer, it first goes to the firewall engine before it goes to your backend services. So in that sense, each and every PSE endpoint is protected from layer 3 or layer 7 attacks. And this gives you the enforcement at the LB layer itself in a centralized fashion. So while protection against known and unknown threat is critical for your defense in depth, we also see our customers trying to improve their security by going through this whole concept of preventative security technologies. So how do you ensure a zero trust architecture and authorize every single request? The way you can do that in Google Cloud is on the load balancer itself, we have integrated with our certificate access management and with IAM. What happens with that is any user or any principal that is trying to access that load balancer gets authenticated. They get authorized based on the policies that you have configured. And once they are authorized, only will they be allowed to access the backend PSE endpoints. Also, we have integrated it with DL. Uh, 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 so this is the cloud. This is the identity aware proxy solution. What it means is that in the IAM, you can integrate IAP. You can integrate your Active Directory users, and all those users who are allowed to access the load balancer will only be authenticated. And in the IAM, you can go and authorize those users, assign specific roles, whether it's a compute read only, GCS bucket write only, Vertex AI read, so on and so forth. And based on that, the load balancer sends the traffic to the IAP under the hood, and the IAP engine looks at the authentication and the authorization piece. One additional capability that the load balancer provide over here is the backend MTLS support between the proxy LB and the backend service. So now your LB is also authenticating your backends and asking for the certificate. And we have also gone into public preview with our front end MTLS, meaning the load balancer is also going to ask for a valid certificate from your clients. So it's a two-way authentication street. And that is very powerful in terms of security, because your users can be all over, and you as a administrator will inject the valid certificates in the load balancer, which will only allow certain clients to access the load balancer itself. Okay, and lastly, we have gone into public preview with this whole concept of integration of Cloud Armor with an internal application load balancer. We always had this capability with an external load balancer. Cloud Armor is our managed DDoS solution. And this was one of the most asked by our customers, that how do we protect our internal load balancers from a DDoS attack? And now we have this capability. So you naturally get the DDoS protection at layer 3 and layer 4 volumetric attacks. But if you want to implement customized rules for service rate limiting, or implement rules for certain signatures like cross-site scripting or SQL injection, you can do that now. So with this, you are also protected from a DDoS attack for all your backend services, whether it's access from within Google Cloud, data center, or anywhere. And this was just a quick example of how I just mentioned about the whole concept of service extension. This is an open programmable data plane. We have released this so customers can inject whichever service they want to, whether it's their own version of API security or custom JWT integration on a load balancer itself. And basically, Google always likes to keep things open programmable. So we want the industry to get us more options over here. There is this whole public white paper on what this service extension is, and there's a good talk that one of our Google fellow gave in the next on this. So maybe if you are interested, let me know. I can point you to the right direction. Yeah, and finally, this whole concept of DLP, data loss prevention in transit. So we are working with third-party providers like Broadcom or WSS Semantic, wherein you can integrate that DLP service using service extension, because it's open programmable, and apply it on the LB itself. So now if the customer, if a malicious attacker wants to exfiltrate data from your BigQuery or from your buckets, they will first go through this DLP rules or DLP engine, and you can avoid the data exfiltration in transit. Yeah, and that is all I had for today. I know I had to rush through things because of the time, but please, if there are any questions, let me know and I'll be around also. But yeah, thank you so much for listening to me. Sure. Yeah. Thank you. Thank you. Sure.
Cloud Run also in. Yeah, that's exactly.
Cloud Armor?
So all these service, if you see, they go in through Cloud system.
Yeah.
However, for Cloud Run service, we use NAT network endpoint. Why?
So for which service you said specifically?
Cloud Run the service.
Yeah, I see. I see. Okay, great question. Yeah. So load balancer itself. Uh, so by the way, this is a proxy LB, right? An application load balancer which has a front end and has a back end, right? So in the front end, you configure the forwarding rule, which is nothing but an IP address and a port. And in the back end, you could have different versions. Now, in Google, for different backend, we have just given different logical names to it, right? And also there are different ways to configure it. So to give you an example, the first three are called PSC backends because they are PSC endpoint itself as a backend. For serverless, the way we kind of call it as a backend, again, that neg is just a logical construct, but that's just the way we have organized it. Now, let's say instead of serverless, if it was a simple VM itself, right, or a GKE node, what we call it as a managed instance group or managed backend. So that's just the way we have kind of based on the compute or the backend behind a load balancer, so that the load balancer can identify whether this is a PSC backend or a GKE backend or a serverless backend. This is just a logical construct. But end of the day, they are all backends.
Yeah. NAT is a
Neg is a network endpoint group.
Yeah.
Yes.
And goes into this Cloud Run.
Yes.
And
Yes.
I'm very clear about what you said. Rest of them, they all use premises.
Yeah, because for serverless, we don't have an option to, at least today, we don't have an option of PSC endpoint to access serverless. So all others are available on PSC endpoint, but serverless is not. Yeah.
And your Cloud Armor in this one, is internal application maintenance. It is L7.
Yes, it is the it only so this one is the internal L7 load balancer, the proxy ALB application load balancer. Yes.
You also mentioned about Power Network.
Mm-hmm.
I know people use Power Network for intrusion detection.
IDS, yes, yes.
And what other service you are also using
So
leverage on Power?
yeah, so that is for IDS. That was like 3 years ago we had launched, right? And that's enabled through packet mirroring, but it's more of a like a detection service, right? It's out of band. I put it that way, right? So the cloud NGFW is the IPS. It's inline service. So it's basically all your threat prevention, TLS, inspecting, encrypting and decrypting TLS, and then sending to Palo Alto engine. So it's basically your full-fledged IPS and threat management system. So no, the IDS is the packet mirroring. The cloud NGFW, which I showed, that just went GA like a couple of months ago. That is your, think of it as a full-fledged firewall, which is inline, and it's not detection, it's prevention, right? So it's happening in real time.
Oh,
Yeah, cloud NGFW. Next gen firewall. Yes, yes. So that's where we are using the Palo Alto engine.
in the Cloud Run, remember if you fly, you traffic come from Cloud Run 2 back to your PC, you can use nowadays egress, direct egress. So traffic is through Cloud Run to your PC. But here in your diagram, you're talking about it from EPC to Cloud.
So since this is an application load balance, you are talking about the DSR, right? Direct server return from the backend.
No, I'm not talking about. We talked for Cloud Run something, but also Cloud Run to connect with your customer PC.
Mm-hmm.
So it is a new service that we it's called direct egress for Cloud Run. So you can directly, let's say, Cloud Run need to access my customer PC some service image.
Okay.
Useful is call to action. Used to be also called that. Used to be is before that came to wireless connect.
I see.
Later on, there is a new innovation called direct impulse.
Got it.
Yeah, from how integrated this.
Okay.
But in your side where you are talking about in flows from VPC.
From the workloads to the published service. Yeah.
All right, that's all my questions.
Sure. Thank you so much. Yeah. If you have more questions, I'll be around. Thank you. Thank you.